Okay, so this is Chemistry Unit Section 2.2, Part 2. So a super short section. So ideally you've already watched this video. If not, you should pause here and copy the link and watch the video. It will also be linked on Teams for things to do this week. It's another crash course video looking at the periodic table's evolution through time. Okay, so we're starting off with organization of the periodic table. In the periodic table of elements, the elements are clearly listed by the order of their atomic number. So remember from before that the atomic number is the same as the number of protons. Metals are on the left. The transition metals range from group 3 to group 12. Nonmetals are on the right, and metalloids form a staircase towards the right side. This is all information based on the diagram in the right corner. So our metals, with the exception of hydrogen, which is a little bit of a weirdo. So hydrogen, you can see it looks a little bit different. It's green because it's not a metal. It's weird. It just sits being the first element based on its atomic number. So the left side is all shown in blue, which is your metals, including the transition metals. And we'll get into groups after, but like it says, the transition metals start at group 3, which is here. So that's group 3, all the way to group 13. The nonmetals are shown in green, you can see on the right. And then your metalloids are the red staircase. So on the periodic table, if we were just to zoom into one box, you would see this. So at the very top, usually in the corner, not in the center, but that too would usually be in the corner, you see the atomic number, which is the proton number. The element symbol is usually the biggest thing. So in this case for helium, it's He. And then the atomic mass, measured in AMUs, is an average, remember, that's why we see a decimal, and it will be listed at the bottom. AMU stands for atomic mass unit. Rows of elements, so going across from left to right, are called periods. All elements in a period have their electrons in the same general area around their nucleus. So basically what this is telling you so far is that a period is a fancy name for a row. So if you go across a row, you are still within one period. Whatever row number you're in is equal to the number of rings or shells of electrons. So think back to Bohr models. So here you can see what looks like a Bohr model. So for example, if we look at period 1, you can see that there is one shell or one ring. Same with over here. For helium, it's still one shell or one ring. Period 2, you're now seeing 2 rings across all of them. Period 3, you're seeing 3 rings across all of them. And period 4, you're seeing 4 rings. So we're basically looking at a Bohr model, which you should recognize from Science 9. There will be a short refresher, though, on Bohr models later on. So new period, which is a row, means that there is a new shell, and a shell is just a ring of electrons. Okay, so next we're going to look at columns of elements. These are called groups or families. All elements in a family have similar properties and bond with other elements in a similar way. So they have similar chemical and physical properties generally within a family. So group 1 are called the alkali metals, and it is important that you know these 4 groups' families' names. So there's a little tiny one up top here that's a little bit hard to see. Column is group 1. So for the first family, we ignore hydrogen again because it's a weirdo, but anything in orange in the first column is called an alkali metal. So these are one of the most reactive families of elements, and the name is not to be confused with group 2, which is here. So this column in red is called the alkaline earth metals. Next, we have the halogens, which are group 17. So right here, shown in this kind of teal, bright blue. And then the noble gases, which are the least reactive elements, are shown in gray. So we generally don't talk about other groups or families other than these four because the consistency within their properties and traits doesn't always hold out quite as well outside of these four families. So the similarities within these families, in these four families, are really obvious, whereas outside of that, they're a little bit less obvious. So looking at this periodic table, you should be able to identify the following things on it. So atomic number, period, group, family, metals, nonmetals, transition metals, metalloids, alkali metals, alkaline earth metals, halogens, and noble gases. The atomic number of any single one of these elements, you should know how do you figure that out, where do you find it on the table, and then going through that list, you should be able to identify and locate those things. Specific families you need to identify are just the four families. So alkali metals, alkaline earth metals, halogens, and noble gases. So you should know where they are, where to find them, and as we move on, you should know some general properties. For example, alkali metals are the most reactive metals, halogens are the most reactive nonmetals, and noble gases are the least reactive elements because they are the most stable. So you can leave this up as you're working, but make sure you finish identifying all of these things. I forgot to say that this is on page 172. So now this is the end of section 2.2, part 2.